I'm very happy to introduce Karthik. Karthik is from Microsoft. He's one of the cloud solutions architect from Microsoft who will be delivering a talk on Citus Postgres. Karthik, thank you so much for taking time out and delivering this one. Thank you.
Okay, everyone. Thank you. My name is Karthik, and I'm from Microsoft. Similar like DB background. I initially started working in Fujitsu as a database administrator for the SQL, and post to that I worked in Toyota. And later on, I worked in Time Magazine and Meredith. Somehow landed in Microsoft as a support services. And now I'm currently working as a solutions architect in Microsoft. So my core areas is into databases, like most of all kinds of databases, structured, semi-structured, or like MySQL, MongoDB, Postgres, SQL servers, SQLMI, and also into cloud, PaaS, and IaaS. So these are my skill sets. Today, my session would be delivering on Citus. Anyone of you aware of Citus, by the way, using it? Glad to know that. Citus is totally an open source, guys. It is actually an extension that is provided for the Postgres. So having the capability of having the Citus, you will have the capabilities of having analytical as well as click that one. Click that one. That's fine. Okay, guys. So I'll be quick. It's okay. So this Citus is totally is an open source which is available for you. It is exclusively for your Postgres. It is an extension that is available. Having this extension, your Postgres has the capability of serving your OLTP systems. High performance is available, but adding the Citus will provide you more benefit in terms of OLAP, analytical processing, especially something similar to your data warehousing, right? Assuming you have a workload where you need to make the both all-in-one feature, right? You want to serve your OLTP workloads, and also there is a special requirement saying that you want to serve your reporting purposes also. In that condition, you always have this feature of going to Citus. Now, Citus is totally an open source. You already have it in your GitHub, and certain repositories are also available over there. What you need to do is you need to just deploy the Citus to your existing Postgres, enhance your Postgres extensions over there, and such that you can leverage these features. That is the main intention of Citus. If you look over there, yes, you can have the scale out of horizontally, which means you will be spinning out multiple nodes. Right, it's similar to like a multiple service serving for your same purpose, and you also have very lightning speed, since there are dedicated storages which will be offered, and also every node has its own CPU, memory, and I/O. This will actually provide you very faster performance because the data is residing with the node itself, and also you will be having local cache. So that is the reason it will be of very, very high speed. And also the beautiful part is you can always simplify your infrastructure, in the sense like you can segregate the type of workload, and also you can segregate the type of storage, and you can serve your purpose. And last, you also have related to a lot of innovations which are coming in Postgres. Similarly, will applicable to all your Citus as well. So there is a version of Citus which is running, and you always have an option to upgrade it any point of a time. This is one very important slide, guys. Like market is trending on this part. The major differences between IaaS, PaaS, and SaaS. Every cloud offering, like AWS or Google or even Microsoft has the cloud computing and fundamentally, if you are an on-premises, all the pillars has to be managed by you. So it's like something like you will be having a data center where the hardware will be aligned to that, CPU, memory, IO, and networking will be done. Finally, we'll deploy an operating system on top of it. Either it might be Ubuntu or Red Hat or Microsoft, whatever it might be. And since the OS is under your control, so definitely this kind of OS management will be under your place. And once the operating system has been deployed, you need to deploy your database, you need to install your instance, installation of instance, and again maintenance comes into your control. And finally, you will be deploying your database on top of it, making sure the mission critical applications, making sure the importance of the application, you will go for high availability or a disaster recovery. High availability means like, where you will place a server which can serve for the availability purpose, right? So you have two servers working for the same functionality that comes under your high availability. And finally, once you have the high availability infrastructure ready, and there will be deploying your data. Data is your production data which serves your production workloads, right? Obviously, the data is connected to your applications. So this is your entire on-premises infrastructure, guys. If you look into an IaaS perspective, IaaS in the sense the cloud is offering you a VM. If you observe, these three colors are are managed by the cloud vendors, whereas the top four will be managed by you, right? If you choose an IaaS, the underlying virtualization, whether it might be VMware or Hyper-V or Oracle VirtualBox, whatever it might be, managed by your cloud vendors, and finally you will be provided with the operating system. So this comes under your IaaS platform. And again, once your operating system is there, you will install your respective instance, OS, and also high availability on top of it, right? So now coming to your PaaS, PaaS is specially a case where entire infrastructure is managed by your cloud vendors, right? So whether it might be an Amazon or Microsoft or Google, so they will manage the infrastructure for you, and finally they will offer the service for you, right? So if you are looking for Postgres, Amazon has its own, and even GCP has, and Microsoft also has. Microsoft has two or three flavors related to that, but the service will be offered, and finally you will leverage the service and you will deploy your data. It's a very important thing, guys, because day and day out you will be working on cloud thing. Moving on to your next very important thing. Here you have Postgres at the
Karthik,
center.
one question.
Yes, please.
Can you go back to the last slide? So off of this entire gamut of IaaS, PaaS, and DPaaS, right? What is accessible to the user in open source versus what is very, very specific to Azure customers?
Great question. See, if you look into the IaaS perspective, if once the VM is being hosted, so underlying infrastructure is only managed by Microsoft. Whatever the extensions you want to deploy, including Citus also, right? If you want to deploy, you will go for the repositories and deploy it in the IaaS machine. That is something which is under your control. But only the hardware is in the control of the cloud vendors. Similar applies to your PaaS, but in the PaaS, the instance level settings or maybe the instance level also is controlled by the cloud vendor. Let's say, for example, there is a specific version of Postgres which you are looking for. Then you need to select that respective option and deploy it. So this kind of, you'll say like compatibilities here are available for you, which version you want to opt for, which is your requirement, that kind of settings will be available for you. And coming to Citus perspective, Citus is totally a PaaS service available in Azure. So if you deploy the Citus, so at a major instance level settings is only things that you can control. Apart from that, everything is managed by the Microsoft, underlying infrastructure and everything. Any more questions, guys? Feel free to open up. Okay, let's move forward. So now we have Postgres at the center. Postgres is a very the Gartner top chart hitter, and very, very widely used by every company in every sector. So now you have the Postgres that is sitting at the center, and this serves your OLTP if you look at a higher level perspective, but you will be adding an extensions to that, which is something but is Citus. Let's take Citus as an extension. Adding Citus to your Postgres, it will offer you the more capabilities of enlarging your open source, right? You want to serve your OLTP workloads. So this is your place. Let's say you want to scale up your resources on the fly, spin up your nodes, spin up your coordinators. So this is again highly scalable, and this can be achievable in cloud. Okay. Now let's understand a bit of architecture, guys. If you look into the application perspective, always application connects to the database, and application consider it's like, hey, where is the database for me? I just want to read, write, and perform the activity. In that condition, generally you have a single node and a multi-node. When you have a single node, the single node will be serving your entire purpose, right? This single node has your CPU memory IO, a bus will be available for you, and it will serve your workloads. But if you look into the multi-node architecture, here there is a separate design, guys. It's an horizontally scaling up, which means whenever you spin your service, whenever you spin your Citus, by definition you are mentioning that, hey, you create multiple nodes, right? It's not a single node that will be serving. And let's understand a bit of transaction, guys. By default, every transaction in multiple databases is series in nature, right? So it will go by step. But if you are looking for a certain parallelism, or where my query needs to execute at multiple places at the same time, and it should fetch the results, this kind of parallel execution can also be achieved by your Citus. So this diagram talks about your multi-nodes, where the center node which you are seeing is called as a coordinator. Coordinator means it's like a masterpiece which will talk with the rest of the nodes. Okay. So this is a depth architecture, guys. If you look into the second part, it says high availability, which is nothing but the same service or the same Citus is also being hosted in another region altogether. So let's assume you are currently working on somewhere in central US, then immediately if there is any kind of abruption, you have a high availability for you. That is the second part, guys, where you can see the coordinator is the main in the architectural diagram. It is a vital point because this holds your entire execution of your data. So let's say someone fires your command, a select query, it has the capability of checking that, hey, this is the data available in these nodes. Why don't I run my code at that place, get the data, merge it, or joins, perform operations on top of it, and finally it will provide the aggregated result of it. So this is at a high level architecture, guys, and obviously if you spin another node in another region, so the coordinator has the capability to talk with the another node as well, right? So you can see the two coordinator nodes are in connection with each other, and obviously your nodes are also talking with each other. So you also have the perspective of scaling up in the sense like, hey, my business is very vast business, right? Let's say somewhere around 15 terabyte or maybe a petabyte is something which I'm touching, and I need high scale, high resources. In that condition, you have an option, guys, where you can scale your coordinator as well, and you can spin up your multiple nodes also, right? You can not only have 2 or 3, you can have multiple nodes. So this is the architectural diagram of Citus, available for your IaaS machines also. It's totally open source. docs.citusdata.com is the website, guys. You can directly go and you can get the repositories from there as well. Any questions on the architectural perspective? Yeah, yes, please.
So the connection between coordinator and worker nodes, if the connection has been lost, so how do you manage this?
Okay, great question. See, if connection is lost is not something that is the way we see, but let's say there is a certain situation where there is a fault tolerance, like a node has been failure for a complete down. So in that condition, generally the rest of the nodes will be serving your full requirement. But let's assume there are only 2 nodes, or maybe there are certain workloads who run it only on one single node, right? Certain workloads can have coordinator and node merging in one node and they can serve that. In that condition, you need to choose HA. HA is your answer for that. But if you don't have HA, probably you can get up to SLA 99.9. So that can be achieved. But node is always having a retry mechanism. Let's say you are serving to a single node, connections got refused. There is a retry mechanism. Automatically, application tries to send the connection to the another node serving your request. So this can be achieved.
In a nutshell, all the worker nodes share the data between themselves?
Yes, there is actually a small trick, guys. It's not something like you go and create a table. There is something called distributed table. You have to be specific with your application workloads. You know, let's assume there is a specific table which needs to be spread across multiple shards. When we say shards, it's nothing but nodes. A single table has been spread across multiple nodes, right? What is the advantage of that? If that table is available on all the nodes, and every node can perform your parallel executions, right? If suddenly someone, and not only in terms of select only, guys, even inserts and updates will be very faster. So let's assume you update at one place in the high availability, then already the data is available in another region. Even the insert and updates gets immediately reflected on your another node also.
So here coordinator itself is a DB or just a
No, it's a meta node. It's a header of the entire service. It's not something. But if you are looking for some cost optimization, something like that, you can merge your coordinator with normal node also. That is also possible. Generally, for high workloads, you actually separate these two. You make sure coordinator is separate and the worker node is separate, right? So having multiple worker nodes serving your request. Any more questions, guys? Feel free to open up. Yes, please. No, this is an open source, totally Citus design. Whatever I've taken is totally Citus design. But the good thing is, like, we have adopted it to us, and this is available as a service in Microsoft Azure. Earlier days, you know, Microsoft used to be some closed platform. After Satya's leadership, it's completely open, guys. So you have a lot of open source available in Azure. And in fact, multiple languages are also supported now. Yeah, definitely. There is a subscription available for you for free. Somewhere around, I think, 12,000 initial rupees will be available. So somewhere around 90 rupees, I think, initial thing. So once you have your subscription, you will be an account admin highest level. Then you can test all these services. Related to Postgres, guys, in Azure, there is one more service called Flexi Server. So that is also available. Single server, Flexi Server, and also Citus. These are the three deployment options which you have in the cloud computing, Microsoft Cloud. Yeah. Only coordinator has a downtime, but not the rest of the worker nodes. Through this concept of sharding. So once you create the table, you should clearly mention that, hey, this table has to be part of your distribution table. Then only the data, actually you have three types of tables, okay? Local table, replicated table, and distributed table. So while creation, you should mention that this is a distributed table. Once you mention, then it will detect like how many nodes are there, and let's spread the data across. Yeah, redundancy is inbuilt, available for you. Yes, please, sir.
If there is a break, if there is something happens, so then you lose the data, right? Whatever is in that node on the first station. On the second node, I don't see that data because that sync replication has gone.
To be honest with you, there is no point of data loss actually, but how we have to see like this is, there is a link that has been broken between your primary and secondary, right? In your high availability, you have primary server and secondary server. There is a link that has been broken. Everything will be piled up, everything will be queued up actually. So all your transactions will be queued up, and once the link has been restored down, it will be pushed up. There is a certain view for that. I think it's some lag time, you know. You can look into that if there is any piled up transactions. Once the link is restored, immediately you will get the data reflected on your secondary node also.
So when I'm putting the second node, on the secondary region, when I'm putting the table which is a single table, where it's not shared, then I will not be seeing the data which is there on the worker or on the first page.
There will be mismatch of data. When the primary and the secondary is there, there will be mismatch of data. Because of network bandwidth or maybe high compute resources, the data didn't get reflected on the secondary. You need to check the lag actually.
Yeah, when I'm coding as a, I would say, when I'm using standard coding or something, then I would still be seeing an inconsistent data. So
If you allow read queries to go through this pattern, then you will see some stages.
yeah, that's right.
And again, it depends on whether you are using sync replication or async replication.
So that's right, because it was a single division, so that
Yes, sync means you will see a
Just one final question on one use cases. How do we apply this in a multi-tenant environment? Probably that's a good use case for this one.
Yeah, there are multiple use cases. One good case is which you have mentioned. Multi-tenant SaaS applications is supported by Azure. So this is one use case. Not only that, you have OLAP analytical workloads. You can consider this like an all-in-one solution, right? I don't know, you studied all-in-one spectrum, books similar to that. It serves your workload, guys. OLAP it serves, OLTP serves. OLTP famous is Postgres, but OLAP it is Postgres plus Citus. Citus will bring that functionality for you. It also supports your spatial times, right? And if you want to store the data in geo, that this also supports. And it also has the capability to pull the data from open sources. Something like copy data commands are there available for you. So you can pull the data from open also. PG Bouncer is supported. Some other extensions which are available are also supported. Yeah, you have. In the connectivity strings you can segregate your workload connecting to respective one node only, right? Let's say your application has a requirement saying that I want to connect to only one node, not the rest of the nodes, where rest of the nodes are connected to another application, maybe another segment. In that case, you have that option. At the end, we'll just offer you connectivity strings, right? Connectivity strings to connect. You have read-write connectivity strings and read connection strings. Read connection strings will be serving your read workloads, maybe reporting purpose also. Workers will talk to each other using the coordinator. Coordinator plays the brain game here. Then individually you can talk to one node also if required. Yeah, read write has to go, but selects can go through particular node if you are intending to. Joins will be multi-faster here, and concurrent sessions can serve you a lot here. I mean, you can have high concurrent connections. Yes, please. Yes, schema change is very required. As I mentioned, there is something called distributed table design. So if you are looking for OLAP workloads, definitely you need to design that. There are many use cases where I know certain customers migrated from Oracle to Postgres, Citus, or maybe they are coming from another DB source together. Definitely they should look into this perspective, because designing is very important. But if you are already, if you want to use it for only OLTP workloads, no need for any designing of table. But you want to serve OLTP workloads, it's actually required.
So when you said the table is sharded, so it's distributed across local nodes. So let us say the table is partitioned into two.
Yes, sir. It will be spread across your nodes. Yes.
So are the transaction guarantees assured here? So
your transaction will have the consistency and durability, all these will be met. But one good part compared with your OLTP here is every node has its own cache and computes here. That is the difference of having a single server and a multi-server. In multi-server horizontal scaling, every server, every node has its own power, right? CPU, mem, IO and cache are there. So definitely coming to normal OLTP, this will serve you more, you will say like acid properties also will be met over here. Durability, consistency will be met. Yes, across all. And this brain for all the nodes collectively working together is coordinator. coordinator plays the game. If coordinator is down, your service is down. But if node is down, your service is not down.
So in the query, for example, I have a any query which has to be across worker nodes. So during plan generation, the communication cost, everything is considered.
Yes, by the coordinator node. Coordinator node plays the main game here. It has the capability to distribute the query. In fact, guys, actually Citus, what it will do is, it will only break the query into pieces. And it has its own language. But application doesn't know anything. But the application people just connect to it and they just see it as in Postgres only. They can't see it as a Citus, because Citus does the entire changes for you. So it will only rewrite the code, it will only send it to the shards, it will only get the data, and it will only merge and give you the result. And application perspective, everything is Postgres forever. Yes, please. Sorry? No, using sharding method only. Feel free, please. How the data is? How sharding happens?
Yeah, how the routing
You see,
data goes to
when sharding in the sense, actually there is a separate query you need to execute. It's a create underscore distribute underscore table. While creating that one, you should clearly mention that this is the key. Okay, I'll give you one simple example. There are many demos available in Citus website also. Let's say, there is a reporting workload. In the reporting workload, there is a very critical column, timestamp. Timestamp is a very generic column. And you also have an ID. So what you decide is, you talk with the application and say that, hey, I will create sharding on this timestamp. So once you say that I create timestamp sharding, so you can imagine like, hey, last year data is on one node. Upcoming year will be on another node. This year data is on another node. So once you serve the query, once you push the query, that query will hit only the place where data is available. How did you do that? By sharding. By creating the table in that specific design. So sharding is the answer actually. Based on that, you need to create the table.
Thank you.
Any more guys? Please feel free.
We understand that coordinator is the brain behind the whole architecture, right? What kind of intelligence does the coordinator bring in? Because there's so many other things the coordinator has to do. I mean, like you explained, the aggregation part, distributing the queries across multiple groups. I believe there are a bunch of other things the coordinator has to do in terms of connection, distribution, and all of that, right? So
Totally agree.
What is the intelligence it is trying to do? Like, other than the conventional any other coordinator?
See, first good thing is generally we don't put workload on coordinator node, not at all recommended. Unless yours is a very small business where looking for cost optimization, you just merge coordinator in this one. Other than that, you will specify the coordinator node only for this segregation part. Your workload is actually running on the node only, it's not on the coordinator. And the second part is, everywhere you get in the connection strings, you get only the coordinator worker nodes only. Because worker nodes is for read purpose. But write connections will hit only the coordinator, right? So connections, inserts and updates will hit your coordinator. It will serve your both regions also in the same time. That is the main challenge it will do. And there are certain cases where we requested customers to scale up, right? They are sitting on a 4-week core with some 500 gigs of RAM, something like that. Based on the, that kind of throttling will be observed on heavy workloads. Once you have that throttling, yes, you can scale up and you can get good performance out of it. Okay, let's move, guys. This is actually the same discussion which we had. You can look into that. The table is very specific, a very straightforward table. Select from table name. And actually, if you observe that node 1 and node 2 are the places where data is available, it will actually segregate. It will only, rewrite the code for you in the Citus language, and it will only execute the query, gather the results, and fetch the application. These all are workload cases, guys. You can look into that, like real-time operation analytics, as I mentioned, totally for OLAP and reporting purpose. None of the OLTP has this capability except your Citus. open source serves this, for you. And you can create indexes, update your statistics, all kind of operations you can do on your warehousing as well. Okay, let's go to next slide, guys. This is also a use case in the sense like which kind of workloads you go for. Yes, transactional OLTP, high throughputs is available. And one more point, every node has SSD inbuilt. So SSDs will provide you very, very high throughputs, high latencies. Since you have such kind of an infrastructure, it can also be used for your OLTP workloads. Okay. This is just a small comparison chart, guys. First of all, PostgreSQL and comparing with Citus is not good because Citus is itself Postgre, right? Extension of Postgre is Citus. So if you take in terms of HammerDB, which is an providing your test benchmark values, right? Postgre serves at 254K, but Citus, as long as the cores get increased, it is like directly proportional. You can serve maximum, maximum performance will be served for you. Okay. Comparing to the next similar chart, it's nothing but your select queries with parallel, parallel performance. If you observe Postgre, it has a high value, but if you see Citus, it serves you very, very faster. Why? Because multiple nodes are working for select query. In Postgre, it's a single query. Okay, so that is the major difference, guys. The lower the value is, the much better it is. Okay, now let's see a small, a small video style like something. It is just showing you, right, this is the distributed table, guys. Something like a sharding table, which you asked for. If you can see here towards left side, it's 91 ms. That's what it is serving. But if you observe, you are doing the same inserts. That too in a multiple nodes, it is serving at 1 ms. Right? You can see the comparison between your left and right. Citus having multiple nodes is serving way faster. Okay, here it is 91 ms. You can see right side it is 1 ms. Okay. So this is the you can say like insert operation. How the way it performs on Citus. Let's go to the final one, please. See, guys, this guy is actually taking a particular Citus and is trying to perform your insert operations. You can see how faster it is compared to first one and second one. First one has 91 ms and around 7102 ms, serving your Postgre, but towards your right side is your Citus, which serves way faster compared to the normal Postgre. So this is the in terms of functionality and the way it operates, guys. That's it from my end. Thank you so much for giving this opportunity. Really so glad. Any questions, feel free to open up. Happy to help. We'll share the deck, and these all are open source links, guys. Docs.citusdata.com, and these are something open you can test for yourselves as well. Thank you so much, guys. Thanks for your time.
Thank you so much, Karthik. That was an insightful session. Any other questions that you may have, right? We will have Karthik's coordinates available on the slides, right? Feel free to reach out if you want to open up a discussion, right? That discussion which will help all the folks on the meetup, right? And all the folks on the channel, right? Pull it up in the Slack channel and then start the discussion, right? We still have 5 minutes, While you are waiting for the next speaker, any questions for Karthik? Any existing problems that you would want to look at, posting for Karthik, right? This is a good opportunity for us to, we have the guy who's on the ground, doing this stuff, right? Taking care of some of the customer engagements and customer deployments, right?
So we would not get these good amount of time with Karthik, probably on Slack channels or stuff. But yeah, I would say leverage this time and look at.
It's simple to keep it, not supporting any company, but so simple that underlying infrastructure is managed by cloud vendor. That's it. So once you say like, hey, Microsoft, you are hosting it. It is just the, the data center, the VM, the clusters, the HA, the instance, everything is managed by your cloud vendor. Apart from that, Citus level capabilities, everything as is. Whatever Citus offers you, same thing is available. You can also yes, same thing you can get. Same thing you can get. I'll give you one example, okay? Why people go for PaaS solutions? Let's take some example like Radio Mirchi or Red FM or something. These are very critical applications. You can't turn off radio, right? People might listen at 1 a.m., 2 a.m. So certain applications require 24/7 availability. For those, you go to PaaS services. You have Citus available.
Karthik, one question I had. Sorry, Romi, 1 second. So, I've been using Citus for a while, right? No, obviously, right, for some customer deployment. So, the one pain point that I always had was there is a model, data model that customer is on, right? And then the customer wants to try Citus DB and then hyperscale extension and stuff, right? The pain point that we have seen is what are some of the changes in the data model, right? I had a couple of, I asked a couple of friends from Microsoft, is there any intelligence, right, that is coming in wherein that schema changes could be migrated and ported so that non-Citus data model and then some magic happens with your utilities and then it becomes a Citus extension enabled schema. Is there any work going on at the moment? It's again, another stuff. We do not want to get into this call, at least, in this discussion, but there is some work going on. Somebody had a question? So, Rumi, if you have any questions pertaining to AWS, right? There are some senior statesmen from AWS, Hari, Rajesh. The guys can answer some of the questions on AWS, right? When we have our networking session, right? Catch hold of these guys, and then all your AWS questions will be answered, right?